to draw a correct and complete, full mark, completely correct rational graph. All right, so I'm going to write you a rational functions here. So let's say we have this rational function fx, which is 2x plus 8, and the denominator is x squared minus 3x minus 10. So sometimes they will give you fx, sometimes they give you y equal to something. So basically it's the same thing. But definitely this is a rational function because we have two parts, two polynomial on top, which is the numerator, and below is the denominator. So how do we start up by drawing the graph? So before we can actually draw a complete graph, we have to do a bit of the analysis. So normally the first step is try to simplify the functions. So what we can do, you try to completely factorize the functions. So on top we can take out the 2, which is your remaining x plus 4. So below is a quadratic functions. You can either use a formula or use a calculator to get the factor. So we will get the 5 and 2. So 5 and 2. So the 5 we take negative 5. The 2 we take the plus 2. Alright, so this is a fully factorized form of rational functions. So from there, it's good to find out the first thing, which is known as your domain. Alright, so to find the domain, as you know that you cannot have a denominator. So to write denominator, normally I'll just write dx. D stands for denominator. So your denominator cannot be 0. That's the first requirement. Because if your denominator is 0, we're going to divide with 0. So it means no solution. Alright, so the domain means denominator cannot be 0. So denominator is x plus 2, x minus 5 cannot be 0. So your x cannot be minus 2 and your x cannot be 5. So these are the requirements. So your domain will accept all the x value except these two, which are minus 2 and 5. Alright, so next information that we can find is known as your x-intercept. Alright, so we go and find out the x-intercept. So to find x-intercept, we will set the y equal to 0. In this case, will be your fx. So it means 0 equal to 2x plus 4. And then here will be at x plus 2, x minus 5. Okay, this, how do we get this? Is because 0 will times the denominator. This 0 times this whole thing will get 0. So 0 equal to 2x plus 4. So basically we just set x plus 4 equals 0. So x we get will be minus 4. So we already have one of the x-intercept, which is minus 4 and 0. Alright, we can actually can start sketching the graph. So the graph I put it here. So we have the first intercept, which is minus 4, somewhere here. So I just put a minus 4 here, right? And there's the only x-intercept we can find. Alright, of course with x-intercept, the other one will be your y-intercept. So we go and find out the y-intercept. So to set the y-intercept, we have to put the x becoming 0. So all this becoming 0. 0 plus 2, 0 minus 5. So on top we will get 2 times 4, we get 8. Below we get 2 times minus 5, we will get minus 10. So simplified, we will get minus 4 over 5. So that will be our y-intercept, 0 minus 4 over 5. Alright, put it on the graph as well, minus 4 over 5. So let's say by estimation is somewhere here, minus 4 over 5. Okay, with this information, we can't draw the graph because if you look at the graph here, we only have two intercepts. We don't know how the graph look like. Okay, so we have to continue doing more analysis here. So we have not finished yet because there'll be more things for you to find. Okay, so the Of course, as you learn in the class, we know that rational functions, this is your rational function. They have something very important to guide you to draw the graph. They call it the asymptotes. So we will have two different asymptotes here. So the first one is known as your vertical asymptotes. The second one is known as your horizontal asymptotes or oblique asymptotes. So you need to know how to find these two types of asymptotes. All right. Okay, we will find the third information. So the third information that we will have to find will be known as your vertical asymptote. So I just call it VA. So to find VA is very similar to how you're finding the domain. The step will be the same. You take the denominator, but this time you set it become 0. I want you to compare these two parts here. To find domain, you set dx cannot be 0. To find VA, you set dx equal to 0. Alright, so follow the same step here. X plus 2, x minus 5 equal to 0. So x equal to minus 2, x equal to 5. You can actually compare these two part answer. You can see there's some connection here. Alright, so the vertical asymptotes you have to label in the graph using a dotted line. So in this case, I'll use a green color one. So we'll locate x equal to minus 2. So here is your x equal to minus 2. So you put the dotted line. Label it. So x equal to minus 2. The second one is x equal to 5. So put it here. Okay, use a dotted line. Label it and make sure you write down the equation. This is x equal to 5. Okay. So we have find out the VA. So next we'll go and find out the HA or OA. So why I put these two together? By the way, HA stands for horizontal asymptotes. OA stands for oblique asymptotes. Because we only can take one. If one exists, the other one don't have. Alright. So so step number 4, you need to go and find out whether is it HA or OA. So to find which one exists, you need to compare the degree. Alright, so the degree. So once again, you look at these rational functions. Degree on top means the degree of numerator is 1. The degree of the denominator is 2. So I just put there, degree of your numerator, which is equal to 1, is less than your degree of denominator, which is equal to 2. So whenever this happens, HA will be exist, OA not exist. Alright, so you need to find the equations of the horizontal asymptotes. If you see that it's fall under this condition, so the HA equation will be fixed, which is y equal to 0. This is a theorem that you need to remember. You see any rational function where the degree of numerator is less than the degree of denominator, we'll definitely get this. Understand? So we will label in the graph. So it's basically the x-axis. So, but you still have to show the dotted line. So this one you label y equal to 0. Okay, with this one, you have already added so much information into the graph, but many students still don't know how to complete the graph. So what I advise you to do on the last step here, so we have already total 4 steps. So one final step, which is step number 5, you can do something known as your, they call it the X intervals analysis. So what do you mean by X interval analysis? That we can split the graph into several parts, and we can roughly know that is it a graph, the part of the graph, is it above the x-axis somewhere here, or is it below the x-axis? So you need to find out the x value that divide the graph into several parts. So how do we find the x value? To find the x value is quite straightforward. So what you need to do, you need to set the denominator, which is this one, becoming 0, and you set the numerator become 0. So once I set, okay, set the denominator becomes 0, you will get minus 2 over here. So we get 5. On top, we will get x equal to minus 4. So we have 3x value. So what you need to do, you have to arrange this 3x value in a straight line from small to big value. So minus 4 is here, followed by minus 2, followed by 5, correct? And both end will be the infinity. Alright, so now you can actually see that we actually divide into how many parts? 1, 2, we have 1, 2, 3, 4. So we actually divide the graph into 4 parts. So what you need to do next is to give or suggest a value within each intervals. And you're going to check the value of the fx. So let's say the first intervals, you can just suggest any value between minus infinity and minus 4. So just give a minus 10. So between, okay, next intervals, second intervals, minus 4 to minus 2, I will just pick maybe minus 3. Alright, the third interval, minus 2 to 5, I will just pick 0. And 5 to plus infinity, I'll just pick, let's say, 10. Alright, once you have chosen all these numbers, so what you need to do, like for example, the first intervals, minus 10, we have to plug into the equation. So you take minus 10, you put into here, minus 10, minus 10, minus 10. And you check whether the answer is plus or minus. So you do it one by one. If you take minus 10, put it on top. So eventually you will get negative answer. Am I correct? Negative on top. Okay. So I just put there a negative on top. You put negative below. So here is negative 10. Here is negative 10. So overall, what do you get? You will get negative as well. So negative divided by negative, you will get positive. So we get overall answer is positive. Okay. Continue with the next one. Minus 3 we put on top, we will get plus. Negative 3 put below, denominator. So this one is negative. This one also will be negative. So we get this one overall will be negative. This one overall will be negative. So negative times negative, we get a positive. So overall will be positive. Okay, 0 on top will be a plus. Below will be a negative. So plus divided by negative, we will get negative. Okay, 10 on top positive. Here will be positive. Here will be positive. So overall, of course, will be positive. So I want you to focus on this part of answer. So this part of answer actually gives us some idea about the graph. Alright, I think I make a mistake here. So repeat again for the first intervals. As you can see, between minus infinity and minus 4, we pick the number minus 10. So if we plug in minus 10 in the numerators, we will get on top is negative. Yes, which is correct. But there's a mistake at the denominator. If we plug in minus 10 at the denominator, so this bracket, first one we get is negative. The second bracket we get is negative. So negative times negative, we get plus. So basically it's a positive at the denominator. So negative divided by positive, we actually will get a negative answer. So the first interval show that is negative means that the graph is actually below. So this is actually referring to below. Below what? Below the x-axis. So anything show plus means above. Anything show minus, again below. So this one above. So based on this, we can actually get an idea about the graph. So between the intervals minus infinity and minus 4, there's a graph below the x-axis, so somewhere here. So there's nothing on top here, there will be somewhere down there. So, and this is an intercept. Of course, this one we have to cross over here like this. So when you cross over here like this, you can see asymptotes. So I want to show you what is meaning of asymptotes. Whenever we have a graph approaching the asymptotes, you have to draw something like this when you're getting closer to the asymptotes, but you're not going to cross over the asymptotes. All right. Okay, on the second interval, which is -4 to -2, which is this part, the one that's shown by my mouse here. So -4 and -2 will be this part. As the analysis show here is something above, so which is correct because it's going up. There's nothing below here, there's something above. So based on the graph, and there's a VA approaching, so we have to follow it closer, but don't cross over. All right. So look at the third intervals, which is between -2, which is here, to 5. So means this whole gap here, this whole thing here, this part and also this part. So that's why you have two parts, the one on top, the one below. So how do I know is where? So the graph here show that it below. So there's something below here, nothing above. And there's a y-intercept and you have 2 VA. So the graph will be something like this. Cross here, approaching here, make a turn, and then approaching this line. Okay? The last intervals will be from the 5 to plus infinity. So it's something above. So means it's these intervals here, this whole things here. So there's something above, so means above the x-axis. So draw it something like this. So this is one example of rational graph. You can see that the graph is actually discontinuous. All right, the graph is said to be discontinuous in the meaning of you cannot complete the graph drawing the whole thing without lifting up your hand, because you have to draw this part, then your hand you have to lift up your pen and then continue with this paragraph and then follow by this paragraph. So make sure it's smooth and no sharp corner. All right, and the graph also actually satisfied the domain because we don't have any graph at x equal to -2 and also x equal to 5. All right, I will show you more example in drawing this rational graph. Basically, these are the steps that you need to know how to draw the graph. All right, thank you.